Hello everyone, welcome back to your own chemistry channel and you are watching DMG chemistry classes. And in this video, I am going to discuss another experiment related to thermochemistry. And the experiment is determine the heat of solution of potassium nitrate in water at room temperature calorimetrically. But before coming on to this experiment, let us quickly define enthalpy of solution or the heat of the solution. So it is the heat evolved or absorbed when 1 mole of a compound is dissolved in such a large excess of the solvent so that the further addition of the solvent does not produce any heat change. So this is the definition of enthalpy of solution. So now let us explain this definition, and for explaining this, let us consider that we have a container having 1000 ml of the solvent or water. तो हमारे पास ये कंटेनर है and it is having 1000 ml water. Now I want to dissolve 1 mole of potassium nitrate in it. Now I am going to dissolve 1 mole of potassium nitrate in it. And we know that 1 mole of the potassium nitrate will be equal to its molecular mass, and its molecular mass is 101 gram. This means that I am going to dissolve 100 gram of potassium nitrate in this 1000 ml of water. Now when I added this 101 gram of potassium nitrate in water, 1000 ml of water, then it is not dissolved completely. तो जब मैंने ये 101 ग्राम पोटेशियम नाइट्रेट को 1000 ml वाटर में ऐड किया तो ये कम्प्लीटली डिज़ोल्व नहीं हुआ, ओनली इट डिज़ोल्व पार्शियली, मतलब इसका कुछ पार्ट डिज़ोल्व हो गया एंड सम अमाउंट रिमेन अनडिज़ोल्व्ड. तो लेट अस सपोज दैट द 70 ग्राम of the potassium nitrate has been dissolved in it and 31 gram remains undissolved. Okay, now further the dissolution of potassium nitrate is an endothermic process. जब पोटाशियम नाइट्रेट जो है वाटर में डिज़ोल्व होता है तो ये हीट एब्जॉर्ब करता है वाटर से भी और द कंटेनर से भी जिसमें हमने ये वाटर लिया है. तो इसका जो डिसोल्यूशन है वो कैसा है, एंडोथर्मिक है. दिस मीन्स दैट व्हेन दिस 70 ग्राम ऑफ पोटाशियम नाइट्रेट विल डिसॉल्व इट विल एब्जॉर्ब हीट फ्रॉम द वाटर एंड द कंटेनर, और जो हीट ये एब्जॉर्ब कर रहा है वही है आपका हीट चेंज या इंथैल्पी ऑफ डिसोल्यूशन ऑफ दिस 70 ग्राम. ओके, नाउ व्हाट आई डू, आई ऐड मोर 500 ml वाटर इनटू इट, into this container. Then due to the addition of this extra solvent, the remaining 31 gram of potassium nitrate will get dissolved. तो जब मैं एक्स्ट्रा 500 ml पानी और डाल रहा हूँ तो जो रिमेनिंग 31 ग्राम है वो भी डिज़ोल्व होना शुरू हो जाएगा और वो भी फिर हीट एब्जॉर्ब करेगा वाटर से और कंटेनर से. इसका मतलब कि जब मैंने एडिशनल वाटर डाला तो वहाँ में इस कंटेनर में फिर से हीट चेंज आया, मतलब डाइल्यूशन के बाद क्या आया, हीट चेंज आया. लेकिन जब हम हीट ऑफ सॉल्यूशन को डिफाइन करते हैं देन दिस इज़ नॉट द केस. इन केस ऑफ हीट ऑफ सॉल्यूशन वी टेक लार्ज एक्सेस ऑफ द सॉल्वेंट. हम काफ़ी ज़्यादा क्वांटिटी में सॉल्वेंट लेते हैं. ओके, और इस क्वांटिटी में वी ऐड 1 मोल ऑफ ए कंपाउंड, और फिर इस एक्सेस ऑफ द सॉल्वेंट में हम लोग 1 मोल ऑफ किसी भी कंपाउंड का ऐड करेंगे एंड दैट 1 मोल ऑफ द कंपाउंड विल बी डिसॉल्व्ड इन दिस सॉल्वेंट एट वंस. एक ही बार में वो सारा का सारा जो कंपाउंड है वो इसमें डिसॉल्व हो जाएगा. अब मैं अगर इस कंटेनर में और सॉल्वेंट डालूंगा, एडिशनल सॉल्वेंट डालूंगा, तो वो सॉल्वेंट जो है अब कोई भी हीट चेंज प्रोड्यूस नहीं करेगा. क्यों? क्योंकि द कंपाउंड हैज़ ऑलरेडी बीन डिसॉल्व्ड इन द एक्सेस ऑफ द सॉल्वेंट. सो दैट्स वाई द डेफिनेशन ऑफ, और जो हीट एब्जॉर्ब होगी वो क्या होगा, आपका इंथैल्पी ऑफ सॉल्यूशन होगा. इसीलिए जो इंथैल्पी ऑफ सॉल्यूशन है इट इज़ डिफाइंड एज इट इज़ द हीट इवॉल्व्ड और एब्जॉर्ब्ड व्हेन 1 मोल ऑफ ए कंपाउंड is dissolved in such a large excess of the solvent so that further addition of the solvent does not produce any heat change. Okay, so this is how we define it. Now let us come to the experiment. And yes, here I have written the enthalpy changes for some compound. So the enthalpy of a solution for ammonium chloride, here 1 mole of the ammonium chloride is getting dissolved in water, and the enthalpy change for this reaction is 16.2 kilojoule per mole. This means that dissolution of ammonium chloride is also endothermic. It dissolved with the absorption of heat. And similarly, the enthalpy of solution of your sodium chloride is plus 5.0 kilojoule per mole, and its dissolution is also endothermic. But it doesn't mean that every compound dissolves with the absorption of heat. There are some compounds which dissolves with the evolution of heat. Example is sodium hydroxide. When we dissolve 1 mole of sodium hydroxide in water, heat is liberated, and you will find that the temperature of the water will increase after the dissolution of your sodium hydroxide. जब सोडियम हाइड्रोक्साइड को या उसके 1 मोल को हम काफ़ी एक्सेस वाटर में डिज़ोल्व करेंगे तो हीट इवॉल्व होगी, और हम ये पाएंगे कि जो टेम्परेचर है आपके वाटर का वो बढ़ जाएगा, तो उसका डिसोल्यूशन एक्सोथर्मिक है. सो नाउ लेट अस कम टू द एक्सपेरिमेंट. फर्स्ट ऑफ ऑल I will write the requirement of this experiment. So requirements are calorimeter with lid and stirrer, then 1/10 thermometer, and I have explained it in my previous video. Then 5 gram potassium nitrate, hot water, cold water. Hot water and cold water is for the determination of the water equivalent of the calorimeter. Hot water, cold water, and beakers, etc. So these are the requirements of this experiment. Okay, now let us write the procedure of this experiment. The first step of the procedure involves the determination of the water equivalent. So first of all, we will have to determine the water equivalent of the calorimeter, and I have explained the procedure, observations and calculations related to the determination of water equivalent in my previous video. So all these things are going to remain as such in this experiment also, and we have to determine what. So step number 1 is determination of water equivalent. ठीक है, और इसका प्रोसीजर सब कुछ हमने डिस्कस कर लिया है प्रीवियस वीडियो में. ओके, then the second step will be step number 2 is determination of heat of the solution. Determination of heat of solution or enthalpy of solution. So now let us discuss the procedure for the determination of heat of solution. So first of all, we will determine the water equivalent of a calorimeter. Then we will go for the determination of heat of the solution. Okay, and for the determination of heat of solution, we will take 1000 ml cold water in the calorimeter. Okay, after making it empty, that is after the determination of a water equivalent. तो वाटर इक्विवेलेंट को डिटरमिन करने के बाद हम कैलोरीमीटर को बिल्कुल एम्प्टी कर लेंगे, उसको रूम टेम्परेचर पे आने देंगे. देन वी विल अगेन टेक 100 ml water in it. Okay, and then we will note the temperature of this cold water and let it be T4 degree Celsius. So the temperature, so let the temperature of cold water is equal to T4 degree Celsius. Why T4 degree Celsius? Because the T1, T2 and T3 will be the temperature of cold water, hot water and mixture during the determination of water equivalent. That's why in case of heat of the solution, the temperature of the 100 ml cold water will be equal to T4 degree Celsius. So this is the first step. Now in the second step, we will add 5 gram of your potassium nitrate in the cold water taken in the कैलोरीमीटर. फिर जो हमने 100 ml कोल्ड वाटर लिया है कैलोरीमीटर के अंदर, उसमें हम 5 ग्राम पोटाशियम नाइट्रेट डाल देंगे एंड वी विल मिक्स इट प्रॉपरली विद द हेल्प ऑफ स्टरर. फिर ठीक ढंग से इसको मिक्स कर लेंगे एंड देन वी विल नोट द टेम्परेचर ऑफ द सोल्यूशन. फिर हम टेम्परेचर नोट करेंगे सोल्यूशन का एंड लेट द टेम्परेचर ऑफ द solution is equal to T5 degree Celsius, and you will notice that the temperature of the solution will be less than the temperature of the cold water. हम ये देखते हैं कि टेम्परेचर जो है सॉल्यूशन का टेम्परेचर कम है किससे, कोल्ड वाटर के टेम्परेचर से. This means that the potassium nitrate has dissolved in water with the absorption of heat. तो जब इसका मतलब ये हुआ कि जब हमने पोटाशियम नाइट्रेट को वाटर में डिज़ोल्व किया तो उसने हीट एब्जॉर्ब कर ली, जिसकी वजह से टेम्परेचर फॉल हो गया. ठीक है, और आगे हम एक्सप्लेन करेंगे कि कहाँ से किस किस से पोटाशियम नाइट्रेट ने हीट एब्जॉर्ब की है. सो कीप वॉचिंग दिस वीडियो टिल वेरी एंड एंड ऑल्सो like and share my videos and subscribe my channel. So friends, we also have an alternative procedure to determine the T4 and T5 temperatures, and that procedure is a graphical method. Okay, हमारे पास एक और प्रोसीजर भी है जिससे हम लोग T4 और T5 को नोट कर सकते हैं. एक ग्राफिकल मेथड है. And the first step of that procedure is that we will take 100 ml of distilled water or cold distilled water in the calorimeter and we will note its temperature. Okay, we will note its temperature after every minute for 5 minutes with the help of a stopwatch. तो हम कैलोरीमीटर के अंदर 100 ml कोल्ड डिस्टिल्ड वाटर लेंगे और फिर स्टॉप वॉच को ऑन कर देंगे और फिर आफ्टर 1 मिनट हम लोग उसका टेम्परेचर नोट करेंगे वाटर का. 5 मिनट तक हम ये करते जाएंगे. ठीक है, लेकिन आफ्टर 5 मिनट्स व्हाट वी विल डू, we will add 5 gram of potassium nitrate into the water taken in the calorimeter. Okay, but we will not stop the stopwatch here. Stopwatch will keep running. जैसे ही 5 मिनट तक हमने कोल्ड वाटर का टेम्परेचर नोट कर लिया, उस वक्त हम 5 ग्राम पोटाशियम नाइट्रेट उसमें डाल देंगे. स्टॉप वॉच को बंद नहीं करेंगे. देन वी विल डिजॉल्व दिस पोटाशियम नाइट्रेट completely by properly mixing it in the solution. Okay, then we will note the temperature of the solution after every minute for 5 minutes. तो फिर हम लोग सॉल्यूशन का टेम्परेचर नोट करेंगे हर एक मिनट के बाद 5 मिनट तक. लेकिन हम स्टॉप वॉच को बंद नहीं किए हैं पहले, तो जो सॉल्यूशन की पहली रीडिंग आएगी टेम्परेचर की वो आएगी आफ्टर 6 मिनट्स, देन 7, 8, 9 and 10. Okay, so in this way we will note the temperature of cold water for the 5 minutes, then the temperature of the solution for the 5 minutes, and then we will plot a graph between the temperature and time as I explained in my previous video. So how do we plot a graph? So in this graph we will be having temperature along y-axis and time along x-axis. Okay, so here we have 1 minute, then 2 minutes, 3, 4, 7, 8, 9 and 10. Okay, and here we temperature, this is your 10, 20, 30, okay, like this in degree Celsius, and time is in minutes. Okay, so now let us suppose that when after 1 minute the temperature of the cold water is this, so we will have a point here, and after 2 minutes the temperature of the cold water is this. Likewise, this is the temperature after 3 minutes, then 4 minutes, and this is the temperature after 5 minutes. Okay, and the temperature, then the temperature of the solution will be plotted here. So the temperature of the solution after your 6 minutes, so this is the temperature of your solution after 6 minutes, then after 7 minutes, then 8 minutes, then 9 minutes, and then it is 10 minutes. And then we will join these points like this. Okay, then we will join these points like this. After this, we will draw a vertical line showing the time of mixing. As I said that I added potassium nitrate after noting the temperature of cold water for the 5 minutes. तो जब कोल्ड वाटर का टेम्परेचर हमने 5 मिनट तक माप लिया, फिर स्टॉप वॉच को बंद नहीं किया, फिर 5 मिनट के बाद वी एडेड पोटाशियम नाइट्रेट, then we dissolve that potassium nitrate completely, and let us suppose that dissolution of potassium nitrate in cold water took half minute, that is 30 seconds. Okay, so the 5 minute and the 30 second will be the time of dissolution. So I will draw a vertical line at 5 minutes and 30 seconds. तो इस पॉइंट पे फिर मैं, ठीक है, एक वर्टिकल लाइन ड्रॉ करूंगा जिसको हम बोलेंगे टाइम ऑफ मिक्सिंग. Okay, then as I explained in my previous video, we will extrapolate these lines to this vertical line indicating time of mixing, and then we will extrapolate this line, okay, and it touches this vertical line here. So this will be the temperature of your cold water, that is T4 degree Celsius, and we can read it from here, okay, by just drawing a line which cuts the y-axis here. Understanding? And likewise we can calculate the temperature of solution by extrapolating this line to this vertical line like this. Okay, so this will be the temperature T5 of the solution, and we can read it from here by drawing a line, straight line which cuts your temperature axis at some point. So this is how we can determine the T4 and the T5 temperatures, temperature of the cold water and the temperature of the solution. Okay, now we will discuss the observations of this experiment. Okay, observations. So in the step number 1 we will write the observations for the water equivalent of the calorimeter. तो सबसे पहले वाटर इक्विवेलेंट के लिए जो ऑब्जर्वेशंस होंगी वो लिखी जाएंगी, and I have explained these observations in my previous video. They will remain as such. And the step number 2 of your observations is, that is observation for the calculation of heat of the solution. ठीक है, and the observations are, that is the weight of potassium nitrate taken, it is equal to 5 grams. Okay, then volume of cold water, taken is equal to 100 ml, and after this the weight of the cold water taken will be equal to 100 grams, because the density of water has been taken equal to 1 gram per ml. Then temperature of the cold water, is equal to T4 degrees Celsius, and temperature of the solution is equal to T5 degree Celsius. So these are the observations for the calculation of heat of the solution. Then comes the general calculations, and the general calculations for the water equivalent will remain the same as I explained earlier. So then general calculations, and in step 1 we will have the calculation of water equivalent of calorimeter. Okay, so these I have explained these calculations in my previous video, and they will remain as such. And the step number 2 will be calculation of heat of the solution. And to calculate the heat of the solution, we will first of all measure the fall in temperature, that is fall in temperature of the system, water or the calorimeter. So fall in temperature of cold water, or we will say only the fall in temperature. So the fall in temperature will be equal to T4 minus T5 degree Celsius. As I explained earlier, okay, that when the potassium nitrate is dissolved in the water, then the temperature of the water will fall. This means that the T4 will be more than T5. So there will be fall in temperature, and it is equal to T4 minus T5 degree Celsius. This means that potassium nitrate is getting dissolved with the absorption of heat. And from where it is absorbing heat? So potassium nitrate is absorbing heat from the water in which it is dissolved, from the calorimeter. Okay, because the calorimeter is also the part of the system. ठीक है, तो जो पोटाशियम नाइट्रेट है वो हीट एब्जॉर्ब कर रहा है कोल्ड वाटर से, कैलोरीमीटर से, साथ ही साथ जो हमने 5 ग्राम पोटाशियम नाइट्रेट डिसॉल्व किया है वाटर के अंदर, दैट ऑल्सो बिकम्स द पार्ट ऑफ दैट सिस्टम. ठीक है, तो पोटाशियम नाइट्रेट ने जो हीट एब्जॉर्ब करी है वो करी है 100 ग्राम वाटर से प्लस कैलोरीमीटर से. ठीक है, तो कैलोरीमीटर के लिए वी विल राइट हेयर इट्स वाटर इक्विवेलेंट, because as I explained earlier, water equivalent is the weight of water which absorbs or evolve heat as absorbed or evolved by the calorimeter. वाटर इक्विवेलेंट पानी का वो वेट होता है जो उतनी ही हीट या तो एब्जॉर्ब करता है या इवॉल्व करता है, लूज करता है, जितनी कौन करता है, कैलोरीमीटर। तो कैलोरीमीटर के लिए यहाँ पे हम लोग क्या ऐड करेंगे, उसका वाटर इक्विवेलेंट, वो हो गया आपका W ग्राम। इसके साथ साथ जो 5 ग्राम वेट है पोटाशियम नाइट्रेट का, जो 5 ग्राम हमने कहाँ ऐड किया है, वाटर में, वो 5 ग्राम भी उसी सिस्टम का पार्ट बन गया जिसमें ये सारा प्रोसेस हो रहा है। तो मतलब हम ये बोलेंगे कि दैट हीट इज़ एब्जॉर्ब्ड फ्रॉम द एंटायर सिस्टम एंड दैट सिस्टम कंप्राइजेज ऑफ योर 100 ग्राम कोल्ड वाटर, W ग्राम कैलोरीमीटर एंड 5 ग्राम योर पोटाशियम नाइट्रेट। ओके, सो the weight which is losing heat is 100 plus W plus 5, this much gram, understanding? So इतना weight है कोल्ड वाटर का, कैलोरीमीटर और पोटाशियम नाइट्रेट, जो कि हीट लूज करेगा। और किसको, पोटाशियम नाइट्रेट को जो घुल रहा है, and this heat will be gained by the potassium nitrate. So now I am writing the heat absorbed by 5 gram potassium nitrate, heat absorbed by 5 gram potassium nitrate will be equal to, that is mass 100 plus W plus 5 into specific heat, that is 4.184 into fall in temperature, that is T4 minus T5 joules. So this much heat will be lost by the cold water, calorimeter and 5 gram potassium nitrate, and this will be gained by the potassium nitrate for its dissolution. Okay, so friends, now this heat is for the 5 gram of potassium nitrate. Now we will have to calculate it for 1 mole, and 1 mole is, as I said earlier, 1 mole is the molecular mass. So heat absorbed for 5 gram of potassium nitrate is equal to 100 plus W plus 5 into 4.184 into T4 minus T5. Okay, then heat absorbed for 1 gram of potassium nitrate will be equal to 100 plus W plus 5 into 4.184 into T4 minus T5 divided by 5, and heat absorbed for 101 ग्राम पोटाशियम नाइट्रेट, जो क्या है, पोटाशियम नाइट्रेट का मॉलिक्यूलर मास, और वो होता है उसका 1 मोल। Heat absorbed for 101 gram of potassium nitrate will be equal to 100 plus W plus 5 into 4.184 into T4 minus T5 divided by 5 into 101 joule per mole. So this will be the heat of solution of potassium nitrate. Now we have calculated it for the 1 mole. Okay, so this is the heat of solution of potassium nitrate. And the precaution for this experiment are more or less similar to the previous experiment. First is that we have to use 1/10th thermometer. Okay, then the bulb of the thermometer containing mercury must not touch the bottom of the copper calorimeter, and the mixing should be proper. That is, we should properly mix potassium nitrate in 100 ml cold water. So these are the precautions which we have to observe during this experiment. So this is all about the heat of solution of potassium nitrate, and in my next video I am going to discuss the determination of heat of neutralization of sodium hydroxide and HCl calorimetrically. So keep watching my videos, like and share, and also subscribe my channel, and also don't forget to press the bell icon for the further notifications. Thank you very much. Have a nice time.